Here we're looking at the slope formula, which of course is rise over run. But what I'm going to do to it is change it around a little bit. I'm going to multiply over this x2 minus x1. I'm going to multiply it over to this side. And that looks like this. Now, what I'm going to do is I'm actually going to flip it around. So we have y2 minus y1. This is the common way you're going to see it. And we're going to change y2 to just y and x2 to just x. That gives us the form y minus y1 equals m x minus x1. This is called the point slope form of a line. We of course looked at the slope intercept form, that's y equals mx plus b, or L of x equals mx plus b. That uses the slope and the intercept. In this case, this line uses a point and a slope. The point is x1 comma y1, just a point on the line. And then of course the slope, because the slope is really what a line is. So you need to have the slope to be able to find any kind of a line. We changed y2 to y1 and x2 to x1 because we have to have variables in this for it to be a function. And y and x are the variables that we use. Just like over here, we have a y and an x, or y being L of x and then an x being x. You have to have those things in there. Okay, so if we are looking at any kind of data set and we have two data points on there, and we're asking, well, if we want to create a line that goes through these two data points, maybe to estimate some kind of behavior of the graph, how do we find the equation of that line? Well, it's quite easy because all you need to know is two things to find any equation of a line. You need to have the slope. That's the most important thing. If you don't have that, you can't find anything else. And you need either the y-intercept or a single point on the line. Either one will give you the point slope form or the slope intercept form, whichever one you're looking for. In this case, we do not know the y-intercept because it doesn't cross the y-axis. We're looking for this line here, just averaging that. We're looking for the equation of that line. How do we find it? Well, we have 2 points, and that means we're good to go because we can use the slope formula, which uses 2 points, x1, y1, x2, y2. Let's name them here. This point is going to be point, 4, 9. So x1, y1. I'm naming that the first one because it's the most to the left. And then the most, as you go left to right, that's the first one you hit. As you go left to right, this is the second one. So that's y1. Sorry, x1, y1. This is going to be x2, y2. This is going to be point, let's see, 6, -4. So x2, y2. The slope of this line then is going to be -4 minus 9 over 6 minus 4, -13 over 2. We have a slope and we have, in fact, 2 points now. So we can use the point slope form to find the equation of this line. I'll just use x1, y1 because that's already labeled x1, y1. The point slope form is y minus y1 equals m x minus x1. That's what I just showed you above. Y stays the same. y1 is now 9. M is -13 over 2. x1 is 4. And this is the point slope form of this line. Now this is an equation. We can write this as a function. And this the equation is what this line is. Now, real quick, I'm also going to use now x2, y2 and plug it into here using the same slope and show you a different form. So instead of y1, we're now going to use y2. It doesn't really matter. -4 equals m x minus x1, which now we're using x2 instead, so be 6. Doesn't really matter which point you use, just use a point. Okay, and as you can see, this of course becomes plus 4. Both of these lines define this relationship here. Both of these equations do that. They, however, look different. And this is the reason why that we like to, whenever we have an equation of a line, we like to solve for the slope-intercept form. In other words, get y by itself. So I'm going to do that by distributing this. Negative 13 over 2x minus 4 times negative 13 over 2. The negatives cancel. The 4 reduces with the 2 to 2, so 2 times 13 is 26. Then we just add 9. We get y equals negative 13 over 2 x plus up 4, 5, 35. And that is the slope-intercept form. All we had to do was solve for y. The slope is negative 13 over 2, and the y-intercept is 35. I can show the slope quite easily by just drawing a triangle. I'm going straight down to this point, going over. So this rise here is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units. And we're going down, so it's going to be negative 13. The run is 1, 2 units. And of course, you go left to right, so that's positive. Negative 13 over 2, rise over run. That's the slope. Okay, doing the same process here. Y plus 4 equals negative 13 over 2x. The negatives cancel. 2 and 6 reduce to 3. 3 times 13 is 39. Subtract the 4, and you see we get plus 35, the exact same equation. And that's the key reason why you solve for the slope-intercept form, because it is unique. The point-slope form is not unique. There's lots of different equations that you can get that will define the line. They're all the same. They end up being the same thing, but they don't look the same. The slope-intercept form, however, always looks the same. You will always solve and get the exact same equation. So that's what you always want to do. Whenever you solve for a equation of a line, get the slope-intercept form. Not only is it unique, it's also more useful. It's a simpler expression, I think. Okay, for this next one, we have these 2 points. They're not graphed on here. There's 2 points that we're told. How do you find the line going through them? Well, first off, you have to have the slope. If you don't have the slope, you can't find anything. So I'm going to name them. Let's name this x2, y2, just for fun. x1, y1. So the slope is y2 minus y1, x2 minus x1. Those become plus. We get 12 over, well, that ends up being 0. This division by 0 is undefined. Because we do not have a slope, that means that this is not a function. It's actually a vertical line. And the vertical line passes through the x-coordinate, negative 7. So the equation of this line is going to be x equal to negative 7. It doesn't matter what y is, you always get x equal to negative 7. If you're to graph it, I can graph it real quick. We have 1, 2, 3, 4, 5, 6, negative 7. The vertical line right there, that is the function. Of course, if we have 1 here, then this point is this x1, y1, negative 7, 1 is right there. And then going up enough, you go 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. This is going to be x2. So this was x1, y1, which was negative 7, 1. This is x2, y2. It's just a vertical line. That's all it says. So if m is undefined, we have a division by 0, which we can't do in mathematics. That makes it undefined, so we know it's a vertical line. That's how you can find the equation of it. give it a try in number 2. Okay, as I said, the slope-intercept form is the most useful form. Okay, as I said also, it's unique, and as I'm going to show you, it has the most important information visible. The slope is right there for you to see, and the y-intercept is a starting point, which is helpful whenever you're looking at these kinds of functions. Now, point-slope form is probably easiest to set up because all you need is the slope, which you need anyways for the slope-intercept form, and a point can be any point on the line. I should say that the slope-intercept form is kind of the same thing, except we need a specific point, the y-intercept. But the y-intercept is just a point. It's 0b for mx plus b, right? It's just a point on the line. So this point-slope form is more general, which makes it easier to set up. But as I said before, it is not unique. It is, however, very easy to solve for the unique slope-intercept form. There is one last form that you'll see sometimes called the general form. This is useful when you're looking for specific types of equations or like for specific forms, but it is not very useful when you're working with linear functions. So this is really no reason to ever use this form unless it's given to you. Okay, the slope-intercept form, like I said, is one of the most useful, and because not only does it have the most important information readily there, it's actually, if you need to graph it by hand, which I don't know why you would need to, but it's very, very easy to graph. So we're going to graph this first function here. F of x equals 4x minus 3. Very easy to graph. All we got to do is find the y-intercept, which is at negative 3. That's going to be right here. And then from this point, we're going to use the slope. The slope is 4. Slope is the same thing as 4 over 1, which we know is rise over run. The rise of 4 units means we're going to go up 4 units. So from this point, we're going to go 1, 2, 3, 4 to this point here. Then we're going to run 1 unit. Well, we're here on the 0 point, so running 1 unit moves us here. That means we meet at this point here. You only need 2 points to graph a line because a line will always be defined using 2 points. You can, of course, go from this point, go up 4 more. Let's see, 1, 2, 3, 4 over 1. Just to make your graph more accurate since you're graphing by hand. But you don't need to, just 2 points is all you need. And you just draw a line. Try to make it as straight as possible. That's not very straight, but you get the idea. I'm graphing by hand, so it's not going to be accurate. So that's the equation of this line. All right, now let's look at g of x. G of x is almost the same thing, except now we have negative 2, the slope of 4 though. Negative 2 is here on the y-axis. I'm going to go up 4 units, 1, 2, 3, 4, over 1. And I'm going to draw a line through that. It's not great, but it's by hand, so that's what we expect. These 2 lines, they have the same slope. Because they have the same slope, you can see that they will actually never intersect. This point goes up 4 over 1. This point goes up 4 over 1. There's no reason for them to ever cross. And even though it may look like they do because my drawing was poor, they never do. These are what are called parallel lines. Okay. For h of x, let's do a red one here. H of x, let me also label this. So this was f of x. This one's g of x. H of x has negative 4x plus 9, so we have negative 4. Same thing as negative 4 over 1. So instead of rising up 4 units, we're going to go down 4 units, still run 1 unit. The y-intercept is 9. From this point, we're going to go down 4 units, 1, 2, 3, 4, and then run 1 unit to right there. Okay, go ahead and draw a line there, like that. This is h of x. And this line isn't terribly special with f of x. It does cross it. That means that this is an intersecting line. It just crosses it at some point. Now k of x, we have a y-intercept of -3. That's right here again. A slope of 4, well, that's the same slope as f of x from 1, 2, 3, 4 over 1. That's the same point as f of x, which means it's the same line as f of x. This is the same line. And I have this on here not to, show you that that same line is whatever. That you can have two different functions that have the same equation. They're actually the same thing. They're not unique. Parallel lines had the same slope. You can see that they both had 4, and they never intersect. The same line, however, has the same slope. That doesn't make it parallel, because the same line intersects infinitely many times all the way on it. It will always cross the same line twice, because it's the same thing. And this may not seem important right now, but it is important when you're looking at maybe multiple functions together. And if the two of them simplify down to be the same thing, they're not parallel. They're the same line. So just keep that in mind when you're working with these things. Okay, the next one I'm going to do in blue. L of x. This is going to be a y-intercept of 5. That's going to be right here. And we're going to go, this is -1/4. That's the same thing as -1/4. I can move the negative to the top or to the bottom, but I think it's easier to look at the top. So we're going to go down 1 unit to here. Then we're going to run 4 units. So 1, 2, 3, 4 to here. And drawing a solid line straight through these two, we get this equation. And according to f of x, this is perpendicular. It meets at a 90-degree angle. That may not be apparent from how I've drawn it, because I've drawn it myself. If you draw this on some kind of like Desmos or some other graphing software, it's a lot more easier to see that it's perpendicular, but even then it may not be readily available. And I'm going to show you why I know this is perpendicular in just a moment. But this is how you can graph functions really easily. I should say linear functions. The y-intercept is the starting place. Use the slope to go from that point to some other point, and then draw a straight line through those two things. Of course, using graphing software is much better. Graphing by hand is always some kind of issue. Okay. Now I've said that two lines with the same slope but different y-intercepts are parallel lines. If they had the same slope and the same y-intercept, they'd be the same line, and those are not parallel. Perpendicular lines are lines with negative reciprocal slope. So we had a slope of 4 for f of x, and then if we flip it and then we give it a negative sign, this is what negative reciprocal means. So 4 is the same thing as 4 over 1. You're just going to flip that. That's what reciprocal means, and then give it a negative sign. So if it were negative, it becomes positive. If it's positive, it becomes negative. That's how you can find a slope and a perpendicular slope. So as I said before, f of x had a slope of 4. L of x had a slope of -1/4. So negative reciprocal. I know it's perpendicular. Also, whenever you multiply two perpendicular slopes together, so 4 times -1/4, of course this is 4 over 1, we're going to get -4 over 4, we get -1. You will always see that happen as you get two perpendicular slopes multiplied together. That's the same thing as just saying take the negative reciprocal. Okay, with this information, we can solve a bit more, questions that ask more specific information. So we want a line, the function of a line, that's perpendicular to this function, and it needs to pass through 2, 4. Well, 2, 4 is a point. I'm going to name that x1, y1. And if the equation of a line is perpendicular, we have a point, right? The only thing we need to know to find any function for a linear function is what's the slope. Well, that comes into knowing that if it's perpendicular to L of x, that means it must have a negative reciprocal slope. So m is going to be negative reciprocal. So I just took -3 and put 1 over it. If it were 1/2 here, you do 1 over 1/2, and then put a negative on the outside. Simplifying this, negative times negative is positive, and you just get 1/3. So negative reciprocal, change the negative to a positive, and then flip it, and you get 1/3. Well, we know the slope. We know a point. Let's use the point slope form of a line. Okay, that's going to be y minus y1 is 4. M is 1/3. X minus x1 is 2. And solve for y, of course. We don't want the point slope form. We want the slope intercept form. And for the same thing as, it says 4 over 1, so multiply by 3 over 3. So we're going to add 12 over 3, add 12 over 3. We get y equal to 1/3 x plus 10 over 3. So those are perpendicular lines. This line and this line are perpendicular, and this line will pass through 2, 4. Next, it asks, instead of perpendicular, what if it's parallel? Parallel lines have the same slope, so we know our slope is now going to be the same thing as this one, -3. And pass through 2, 4, so y minus y1 is 4. M is now -3. X minus 2. Y minus 4 equals -3x plus 6 plus 4. Y equals -3x plus 10. And this line is parallel because it has a different y-intercept, but the same slope, -3 and -3. So those are the two lines. Let's graph this and show that it's actually true. All right, so let me turn off this. This is the original function we had, -3x minus 10. That's L of x. We want a line perpendicular to it. That's this first one, 1/3 x plus 10/3. This is our original function. Here's the line that's perpendicular to this. And you can see it does look like it meets at a 90-degree angle. We know that it does because it's got negative reciprocal slope. And a line that's parallel to it, we got -3x plus 10. -3x plus 10 is right there. And of course, both of these lines have to pass through 2, 4. That is the line 2, 4, or the point 2, 4. And both the blue line, which is perpendicular, and the green line, which is parallel, pass through 2, 4. So that shows that they are, in fact, true. Okay, give it a try in number 3.